Hello, XCity here. It's been a while, but today we are back and going to solve Mythical on OneWeb. Mythical is a chain that consists of three machines, two Windows machines and one Linux machine. And you start out with access to a Mythic C2 server that has already been set up, essentially at the customer's location. You could say for like compliance reasons. They don't want any C2 on the internet, so you get access to your own little server inside the environment. You can see after logging in here, essentially you have two beacons. One is a bit old, so it's not calling back anymore, and one that is actively calling back right now. As this user momo.ayase, the domain is Mythical US. So we are a domain user inside the domain and we have a beacon. That's a good starting position. So let's go to interact here. And the first thing I'm going to do to speed things up is to sleep 00. This means it's basically calling back in real time. On a real operation, of course, you wouldn't set the sleep to 0 to give it a bit of time to actually defend itself against memory scans and so on. Okay, so let's gain some situational awareness here. So first of all, let's do a who am I to see who we really are here. We're still this Mythical US Momo.ayase user. It doesn't really show the permissions of our user. We could do shell to issue a shell command and then do net user Momo.ayase. And this gives us a bit more information, right? So let's check groups first. A local group is OpenVPN administrator. This is interesting, right? So apparently there's some kind of OpenVPN running. We are a remote desktop user, so we could RDP in if the networking would allow us. And also she is a member of the backup admins besides domain admins. So something is going on with OpenVPN and backups. To maybe explain the scenario a bit, the idea here is that this company got ransomware, and the scenario is also on the lab wiki. And now they improved a few things, including storing backups no longer online, but on another server, on another location, just VPN in and do the backup. And also they fixed some of the vulnerabilities, or so they believe, which led to the compromise last time. So we're essentially coming now a few months after this compromise to see how things are looking. All right, so let's get some more awareness here. We do maybe an if config to see the network interfaces. And you can see that there's an OpenVPN adapter here, which is right now actually connected. So basically adding to the story, they do store the backups now offsite, essentially, to VPN in to do them. But right at this moment, this machine is actually connected to the backup side. So we probably have a good chance to get there. All right, on the main adapter, we see the IP of the machine itself, right? Okay. Yeah, networking we can do in a second. I also want to explore the file system a bit, so let's check our current path. All right, let's go back 2 directories here, do an ls, and you can see that Mythic has this nice kind of browsing feature here, so you can do it also graphically. Let's check the admin folder here. All right, there is rsync for Windows here. Okay, maybe they do the backups via rsync. Let's see. There's an install folder. Let's check this one as well. There's autologon, there's OpenVPN here, and SQL CMD. So maybe there's a SQL server somewhere as well. All right, we can also check the users folder, I guess. So there weren't many users logged in here, essentially just this Momo user. Okay. So that's already quite a bit of info to work with, I would say. Let's see. Yeah, I think as a next thing, I want to do a port scan to just see what kind of ports are open on the other machines. So let's do register assembly to being able to load the assembly into the client, into the agent, and then run it from memory. I guess in the blog post, I will write where these tools are from in case you haven't heard of them yet. And then we are going to do execute assembly, run the port scanner. And for the host, I'm using 192.168.25.1. Why this IP? Well, if I scroll up, we saw that our own machine has the .2 adapter. So the .1 one will probably be the OpenVPN server. And we want to see like which kind of ports are open there, right? So let's do that. And you can see one cool thing about Mythic is that even though this task isn't even finished, it can still like give the output in real time, like continuously. Not all TC2s can do that, so I think that's pretty cool. We can see that's SSH open, and also there's 873 open. And I hope you recognize this port because it's rsync. And we also saw the rsync client. So I guess it's pretty safe to say that the backups are actually being done via rsync. So this is pretty interesting. But I also want to scan the other machines. So let's check again which IP we had. We have this one here. And the IPs of the other machines you can actually get when you start the machine. Yeah, you basically see all three IPs on the machine pop up when you start them. So let's scan the first machine. Yes. And also let's scan the last machine. So now we should have port scan of all machines. Yeah, so this command I messed a bit up. I was off by one with the IP. So let's see, 246 is actually the Linux machine that we just scanned from the OpenVPN interface, just from the external IP. So you can see there's still SSH open, but the rsync isn't. So the rsync is only listening on the OpenVPN interface. Okay, so I'm also going to scan the other machines now by giving them the real IPs. This one should be the machine we are also on, which is the domain controller. And there's one more Windows machine, which I'm also going to scan here, just to see what's going on here in the network, get some situational awareness, right? So there's SMB open, there's RDP open, there's DNS open. Okay, not too much that's helping us. But the other machine has additionally SQL open. So there's port 1433, which is MSSQL. And there's also DNS. So chances are the other machine is also domain controller. So we might be dealing with two different domains here. I didn't scan for Kerberos or LDAP or anything like that, right? So I just gave it a short list of ports here. Obviously, you could also scan for these ports to confirm that these two are really domain controllers. Let's see if our own machine really is one, right? We can just do shell host name. Okay, we are DC01, so that's for sure a domain controller. And the name of the other one we don't know right now, but it's not really too interesting at this stage, I guess. So to summarize, we have two domain controllers. We are a low-privileged user on one of them in the Mythical US domain, and basically managed to identify the backup server. Let's now actually try to use rsync to access the backup server. So let's see which directory we were in. We are in C, so let's go to admin, I believe it was, and then do an ls. Yes, I want to enter this folder, and then the bin directory, and then we do an ls, and this should be the place where the rsync binary is actually located. Yes. And now we can just run it from the local directory. So let's do shell rsync, and then we list the contents of the rsync on the backup server. All right, there's one share here called Mythical, and this is a comment which says it's for domain backups. This looks pretty good, right? So let's also create an output directory. I'm just going to call it temp here. And then we're going to sync the contents of the backup share to this machine. And apologies if the text is a bit small, but I didn't really see how to increase it in Mythic. It's probably possible, but yeah, better watch it at a PC, and then you can see it clearly like I do. There are two files here. There's a flag. I'm not going to show that. And there's also a KeePass database. So let's go to the folder where we actually copied it. Right, let's do an ls there. And here are the files. And if you want to download a file here in Mythic, you can do actions and download. And it should show like a new thing here. And then it would try to preview the file, which doesn't really make sense if it's a binary file like here. So we're just going to download it and then essentially copy it to our local folder and have a look at it. Okay. let's check this here. We can use keypass.exe, which I have here, and then this file, but it's locked and we don't really know the password. We can try to like do Mythical 2024, like stuff like that, right? But in this case, guessing it's probably not possible. Another thing you would usually do is keypass to John, right, to see if you convert it to a hash. So let's try. Right, but it will complain here. This is actually a real keypass.exe database, and I believe there's no really good way to crack these at the moment. The script can't convert them. Also, I didn't like find any script that can do it. So if you know a way to actually convert this to a hash and crack it, I would be grateful. That would be cool. But I don't know about that. So let's try to find another way. Of course, we can do something really simple. We can try to open it, enter a password, and see if it works. And if you automate that, it actually looks something like this, what I did here. Essentially, let's go to the, this kind of explains it well. We just echo the password into standard in and then call the CLI version of KeyPass, open this, and see if the result is basically giving an error or not. So it's really dumb in this kind of sense, but it works to check a few thousand passwords in a few minutes. So if there's like an easy password, there's a good chance that you would find it with this like really simple kind of way. Let's actually do that. We're just going to do just run the script here with bash, give it a file, and then we have to give it a word list. So let's do passwords, leak database, and then I'm going to give it one of the smaller ROCU lists. There's also a hint on the wiki, which basically says to use one of the lower lists. Just to make sure cracking isn't really the thing you get stuck on here, right? I don't really want to waste anyone's time. You can see it's 1,500 passwords in this list on average. So it takes like 5 minutes to try them out in my small VM here that only has 2 cores assigned. So if you have a better machine, obviously this will go a lot faster. But even on this VM, it's kind of fast enough. Yeah, I'm just going to like Control C here because that's probably not interesting to watch, right? So we're just going to open this now, keypass.exe, right? And then we can open the file. You can see there's one account here called domjoin. I'm not going to show the password right now. So what could this account be about? Well, we have no idea. Just judging from the name, it's probably to join machines to the domain. And maybe we need that later, right? But we're still missing like the basic domain enumeration, like running sharpound, running certify, and things like that, right? We haven't done any of that. So let's go back to Mythic here. And actually, I'm now going to do exactly that. Essentially, yeah, doing the enum that we missed before. So we are going to register both sharpound and certify. Right, so now that they are registered, we can, let's start with certify maybe, do execute assembly, give it the name we registered, and then parameters. So I'm just going to look for vulnerable templates and maybe run like Bloodhound at the same time, I guess. Doesn't really hurt, I would say. So we can do sharpound exe see all GPO local group and run that as well. Right, so there seems to be an issue with the certify here. Let me just run this again to see. Maybe it's a one-off thing. Yeah, so now the certify is working, and the Bloodhound seems to have finished as well. Yes, happy graphing, right? So Bloodhound is finished. We can download the file from Bloodhound. And certify also is finished here. Maybe make this a bit bigger. Okay, certify showed us some stuff about the CA first, and then it found one vulnerable template. This is actually the machine template. So what is wrong here? These flags actually don't look that bad, and it's also not telling us what kind of vulnerability it is. But if we check the permissions, we can see, well, domain computers can enroll, which is not too unusual for the machine template, right? That's totally normal. But also we have write permissions over this template as a domain computer. So if you would get control somehow over a domain computer or could create one, we would be able to exploit this. This is known as Escalation 4, essentially. With write permissions, you can make this template vulnerable to any other escalation vulnerability, for example, ESC1. So all that is really missing for that is domain computers. if you go back here, there's an account called DOM-join here, right? So if this account is able to join machines to the domain, obviously it also has to be able to create a computer account for the machine, right? So maybe this machine can actually do it. So a tool we can use for this is stand-in. Stand-in can create computer accounts. So I'm going to register it here and just try to run it as the Momo user we are right now, just to see if our normal user can already create a computer account, because that would make things pretty easy. So let's just do execute assembly on the stand-in program. Computer should be called XCT and should be created. So let's see if this works. Okay, we get some kind of error. It's not really telling us what went wrong, so maybe it could be some other issue, or we just don't have permission. We really don't know. So what I'm going to try now is to also do it with the DOM-join account that we found in the KeyPass file. So let's do actually here, let's start another beacon. This is the beacon binary that's already on the machine. Why am I starting another beacon? Because I want to separate the beacons by users. You don't really have to do that, but for me, I think it's easy to keep like an overview. So let's edit the description here. This was the beacon from Momo. And this one is the beacon that we are going to use for DOM-join. All right, let's interact here and also set the sleep timer to 00. Then we are also going to register this stand-in assembly here. And then I'm just going to try again to essentially register a computer account, but I can't do it right now because we're still Momo, right? We have to change user first. And one thing you can use for that in Mythic and also in most other C2s is the make token built-in command, which will give us essentially a lock-on as this user DOM-join here. So let's try that. All right, it's telling us we impersonated the user we already are, which is a bit weird, but actually we're now in the context of DOM-join. Not sure why the output is like a bit weird there. So let's try this the stand-in command to make a computer account again. And now it worked. So this DOM-join account really can create computer accounts, which is pretty nice, right? Okay, so now that we have a computer account, we can think about exploiting this escalation vulnerability. So first of all, let's just copy this beacon once more to just have it like separated per user, like I said, right? I'm going to call that $XCT because this is how the machine account is called right now. Let's interact here as well. Do a sleep 00. And then we make a token for this machine account. Let me see what the password was. It's this here. So let's put it here. And now we impersonated this machine account and can do things in its context. I'm going to use Power View here. I guess usually you are used to using 30Py on Python, on Linux, via socks to do this, but you can also do it from PowerShell pretty easily. Let's import Power View for that. So there's PowerView.ps1 here. It's now imported and we can use it now in PowerShell. So just to summarize, what we want to do is make this template, now that we can write to it, vulnerable to ESC1, so we can exploit it from any domain user. So we use PowerShell and then for the first one, add domain object ACL to this machine template. And we essentially add as a principal domain users with this rights UID. These rights, you can look this up online, essentially mean that they can enroll. All right. Then as a next step, we want to do set domain object. This one is actually making it so that you can supply an alternative subject name inside the certificate request, which is like essential for the ESC1 vulnerability. And it wasn't vulnerable to that before. We are just creating the vulnerability right now. So let's do that one as well. And we need one more command here. And this one, again, you can look this up if you're interested in the details, essentially makes it so it can be used for client authentication, which a machine template by default can't really do, I believe. So with these three PowerShell commands, we essentially made this vulnerable to ESC1. So let's also register the, well, we don't have to do it from here, right? Now we made this template vulnerable for all domain users. So we can go back to our Momo shell here. That should be fine. And then we should be able to request a certificate with certify for the domain administrator using the machine template. So this is the command. We just give it the CA, the machine template name, and then for which user we want to have a certificate, and everything worked. This should give us a cert. Let's see. Yeah, so this actually looked like it worked. We get a PEM certificate here. So actually want to convert that in order to use it. So maybe just go here and call it admin.pem, copy it here. Actually, there are some, yeah, let's just copy that again. Now it looks good. And then we, like you saw here, it tells us how to convert it, right? So I'm just going to do that as well. Essentially, we are converting it from PEM to PFX. No password. And now we should have admin.pfx here, right? Okay. So let's check which directory we are in here. Okay, let's go to C admin, I guess, just to have it a bit more clean directory. Okay. Then now that we have the certificate, let's actually upload it here because we want to use it with Rubius on the machine itself. So we can just do upload here and then select the file you want to upload. So let's check. Yes, the PFX is now here. Now we want to register the Rubius assembly, just as we did before. All right, the Rubius is registered. And now let's actually try to use this certificate to get a ticket. We're also going to use this get credentials flag here, which is really nice because it gives us also the NT hash that we can use for pass the hash attacks. All right, we got a ticket here, and also we get the NTLM hash here, which was coming from the get credentials flag. Okay. Well, now we actually want a system beacon. So one thing we can do is use something to allow past the hash attack to get the beacon, right? So I'm going to use a PowerShell script here, which is doing SMB exec. We can now use it like this. We do invoke SMB exec, give it the local host as target, and then of course we want to do it as administrator with the hash we just got, and then as a command we just want to start another beacon, and if everything worked, this should give us a high privileged beacon on the first domain controller. All right, we get a new beacon, and you can see that it's now red here, and this is already a system beacon. So let's also rename this as system. And also, of course, again, sleep 00, otherwise we wait too long for the video. And yeah, we are system on a domain controller. All right. We can also read the second flag now if we want to, but obviously I'm not going to do it here. So maybe now let's check actually if there's any trust between the two domain controllers, assuming they are different domains, right? So let's do PowerShell get AD trust, and then I guess filter wildcard should be good. Yeah, so we can see there is an outbound trust relation with another domain called mythical-eu.vl. Outbound means that all users in Mythical EUVL can authenticate to this domain we are in right now, the US domain, right? But not the other way around. Basically, none of the US users can authenticate to the EU domain. This is pretty sad because we are basically own the US domain, but given this trust, we don't really have an account on the other domain and can't access anything, right? Well, almost. There's one way to abuse this by using the trust account. So when this trust is actually set up, it creates in the EU domain an account for the US domain, and in the US domain, it also creates an account for the EU domain. So if we do mimikatz LSA dump trust patch, we should get the hash and also cleartext password of this trust account. So this worked. We can get the cleartext password here. Well, in this case, it's not user set, so it's unprintable. But the hash will be like good enough for us at this point, right? So maybe, let's see, maybe we duplicate the beacon again to now switch into the context of this trust account. Let's call this trust. We can do again asleep 0, 0. Okay, so now in this new beacon, let's register Rubius. Then we are going to use Rubius for pass the hash. So we get the ticket imported from the trust account. Let's see if I put the correct hash. I think I might have put a wrong one. Let's try again. Yes, now we get the ticket of the trust account, and we are essentially in the context of this trust account. Well, now with the trust account, we can enumerate things in the other domain. You can do things like certify again. You can do sharper and all of that. I'm going to do, first of all, share enumeration with PowerShell script. So let's do that. Now we got the PowerShell imported, and well, the script can also take a hash, so we can also pass the hash here. We don't really have to do it because we imported the ticket, but we can also do it like that. And now SMB enum, like for the target, I guess we want not localhost, but the other IP of the third machine, right, of the other domain controller. Let me look up which one this was. Yeah, so it's this one actually. Let's run this and see if it can actually list the shares. I messed this up. Of course, it's not invoke smbenum.ps1 for the like invoke command, right? So that's an error. Let's actually grab the IP here, copy this command in again, this time without the ps1 on the command. Obviously, that's just the name of the file, not the name of the command, right? Let's see. Okay, it looks like it failed authentication. Yes, I'm having some trouble with the SMB enum script right now. I'm not sure what the issue is, but we can also, of course, just use shell, right? So maybe since we obviously can't access $C, we could also try netview on this machine here and see if it lists us the shares this way without relying on the PowerShell script, right? We can use the Windows built-ins. All right, this also lists the share, so we don't really have to use this PowerShell script after all. We can see besides this wall and netlog on, there's also a dev share. So let's check if there's anything in this dev share. Again, we can just use our shell here, just list the contents of this dev share. Okay, so there is essentially two binaries. There's the auto logon again, just assuming that's the one from sysinternals. Maybe we want to download this get users.exe. So we can also do that from here. It should work like this. And then the file name. And yeah, this also works to download the file. And now we got the get users.exe file here. Here we go. Let's full screen that. That's the get users binary. It's a .NET binary. So let's just see a program here. This is like collecting users from LDAP or something, but we can see there are hard-coded credentials in it. So we probably want to check them out. So we got credentials for this SVC LDAP account, right? But we didn't really look at Bloodhound yet. But just judging from the name, the LDAP account probably can't do too much, right? LDAP is usually like a read-only query type of account. But I'm still like interested in what kind of users the other domain has. So one way to query the users of the other domain is using the PowerShell AD module. which is essentially already installed since this is a domain controller, exists by default, right? So let's check the user names first. We can see there's SVC LDAP, but also there's SVC SQL and a very suspicious root account. So let's think about password reuse scenarios, right? So this password we got could maybe be for one of the other users. And you can spray that, for example, with PowerShell. But in this case, well, there's two service accounts. Let's just see if it also works for the other service account. And if it would work for the SVC SQL account, maybe we can log into the SQL server with that, right? Yeah, so I guess this sounds like a plan, right? So maybe that's just yeah, let's purge the beacon here. I'm not going to duplicate it. So now if we do Rubius purge, it will basically throw out the trust account here. And then we can create a new token. I'm going to use the Mythic make token thing here. Let's see. This should be done. Yes, purged. And then we do make token for the SQL account, hoping that it's the same password as the LDAP account. And you can see that this didn't seem to fail. So let's actually try to use that to log in. Yeah, first of all, I'm going to use this SQL CMD binary that was already on the machine. I'm going to copy that here to admin and call it abc.exe. Why am I doing that? It seems a bit unnecessary, right? I noticed that sometimes Mythic would screw up if CMD appears in the binary name. I'm not sure why that is. Maybe that's just on my machine. Yeah, I don't know. But in order to get around this, I basically renamed it. So now we have to craft the SQL CMD command to actually connect to the SQL server. Just a simple example here. Now remember it's called abc.exe. We give it the server with the syntax, and then we just put some generic query here to just see if the SQL connection is working from our SQL SVC Windows logon. Because we're not providing credentials here, right? We're using the Windows logon to query the database. And this actually worked. Well, you can see one issue here. It says processed, waiting for more messages. The reason is that if you do a small queue here, it will stay like in a kind of interactive mode. And if you do a big queue here, it will just end the query afterwards. So what we really want is the big queue there, of course. So now let's continue enumerating this SQL database, right? This SQL server. So one query I just did is this one here, which is basically state from Actrix. It's analyzing which of the databases have the trustworthy flag set. If there's a trustworthy database and you are also one of the owners of the database, you can escalate privileges to one of the other owners of the database. And in case of MSDB, the other owner will be the SA account. So this allows our user to potentially escalate privileges on the server in case we are also an owner of this MSDB database, which we don't know yet. So this next query here, which is also state from Hactrix, essentially lists all the database roles on this database, and you can see that one of the owners is DBO. This is default, and another owner is our account. So we will be able to escalate privileges from this account to this account because they're both owners. That's the vulnerability here. So let's do that. If you want to know how to exploit this, I'm also going to put the commands on the blog post to this video, but you can also find some information on the internet on how to escalate from DB owner to sysadmin. So I'm just going to put the commands here. First of all, we create store procedure, which I'm just calling XCT here, and it will basically the store procedure will add our user SVC SQL to the sysadmins directly, and then we execute this. Well, that timed out, so let me double check. Yeah, I think I had a wrong IP there, so let's try again. Okay, this finished, and now we're actually going to run this procedure, and hopefully we are sysadmin after this. I see no errors, so let's try to enable the XP command shell. And already from this output, you can see there's no access denied. So it must have worked. We are sysadmin now. Let's now enable XP command shell. Before we just enabled the show advanced options, which is a requirement for that. This also seemed to have worked, so now let's just run a command and see if we got command execution on this other server. And yeah, this works. We are now in the context of the MSSQL $SQL Express account, which is one of those default service accounts if you install MSSQL Server on any Windows server. Now we kind of want a beacon as that user, right? So first of all, I'm going to create a temp directory here on DCO1. Let me see. Oh, temp already exists. Okay, maybe I did it earlier. So the idea is that I'm now going to share this folder so everyone can access it. And this means that also the DCO2 with the SQL server will be able to access this share. So now I'm going to copy the beacon that is in program data or whatever into this temp folder, so the SQL server can actually reach it over SMB. Let's see if there seems to be some kind of error here. I'm not sure why that fails. Maybe we just download this and then upload it. Maybe switch to the folder and then upload it again. So now it's hopefully here. Yeah, it's here. So yeah, I don't know why the copy didn't work, but this is like good enough, I would say. So now all we have to do is really use the XP command shell to run this beacon binary of our SMB share. And if all works, we should get a beacon as the service user. Maybe I didn't mention it before, but AV is turned off here. So this is like a practice scenario for Mythic. You shouldn't really have to worry about AV here. Yeah, and we got our beacon here as the service account on DCO2. So again, sleep 00 to make this interactive. And as you probably know, if you have a service account on Windows that's not like specially configured, you can usually exploit the SE impersonate privileges to become system. So I'm also going to do that. We are going to register one of the potatoes. I'm using the EFS potato here. All right, it's registered. Now let's run it. And again, we can specify the program that's being run, and we're just going to use our beacon on the SMB share again. And if all work, this should give us a system beacon on DCO2. Oh, I used the wrong IP. I'm stupid. So let's do it again. Obviously, 274 is the IP of DCO2, so this won't work. Yeah, this looks better. Now I use the real IP, and we got a system beacon, I hope, yes, on the domain controller too. And we are sort of done here already. The only thing really left is that if you want to read the flag, it will tell you the flag is in memory. So to actually get it, you can use the built-in logon passwords command from Mimikatz from Mythic, and this will work here. Again, there's no AV, so this should just be a quick command to actually get the flag from memory. Right, so I'm not going to show the full output, but you will find the root flag inside here. That's it for this chain. I hope it was somewhat helpful, and if you want to try it out yourself, as always, you can go to warnlab.com, basically get your lab access there, and then jump right in. So thank you for watching, and see you next time.